It's much more common for you to not know what the population standard deviation is. So if an estimate of the population standard deviation sigma cannot be developed prior to sampling, we can use our sample standard deviation S as an approximation for our sigma value. So this is going to be the case of the sigma unknown. So for this situation, the interval estimate for our population mean mu is going to be based on our t-distribution. And we're going to assume for now that our population is normally distributed. So the good news is that the confidence interval for our population mean looks the same as in our previous discussions on confidence interval, except this time now we're looking at the sample standard deviation and we're looking up our t-statistic on the t-distribution table rather than looking at a z. So here to look at the confidence limits, we have our equation here. When you look at your sample mean plus or minus your t-statistic times the sample standard deviation divided by the square root of n. So in most sampling situations, the population standard deviation is not known. So this is actually what you're going to work with most of the time when you're looking at that margin of error. So the t-distribution allows for us to use the sample standard deviation to estimate our population standard deviation when our population standard deviation is not known. So here we're going to look at the t-value. We're going to start with degrees of freedom equaling 14, and we're going to start with a 95% confidence interval. So if we're looking at a 95% confidence interval, that means the area in red is 0.95. And then the area in the far right tail is going to be half of what's not inside my confidence interval. So if 95% of my observations are in the red area, that means 5% is outside in the tails and it's equally split. So my upper tail portion is only going to represent 0.025. So what that means is I need to find the t-value associated with the alpha divided by 2 of 0.025 with 14 degrees of freedom. So the way I find my t-value is I go to my t-table, I go down to I read the top saying that these are going to be the areas that are in the right tail. So what that means is we're looking for that gray area in the upper right hand area. And so then I go down to 14 degrees of freedom and match it up with the t 0.025 to get the t statistic of 2.145. So now, if I go back to my discussion of meal heights, if my sample size is 15 and my sample mean is 5.72 feet with a sample standard deviation of 0.31 feet, we can construct a 95% confidence interval for our population mean by using our t-statistic instead of a z-statistic. So here if I do 5.72 feet plus or minus that 2.145 that we looked up on the previous slide, times my sample standard deviation of 0.31 feet divided by my square root of 15, I can end up with a confidence interval of 5.55 feet to 5.89 feet. So what this means is the amount that I've added or subtracted to or from my sample mean is going to be called my standard error of the sample mean. So here it's 0.17. So we are 95% confident that our estimate is plus or minus 0.17 feet of our actual value. So now let's look at calculating a 90% confidence interval. So remember with t-distributions, we have to define them based on their number of degrees of freedom. So we're going to stick with our 14 degrees of freedom. Since we have a 90% confidence interval, that means the area outside or not shaded in red is going to represent 10%. So that means my tail is going to be 0.05. So now I need to go to my confidence table. I'm still looking for that gray area, so I'm going to start with 14 degrees of freedom and go to the T alpha of 0.05 to get a t-statistic of 1.761. So when I go to calculate my confidence interval, I'm going to use that 1.761 as my t-value. We have the same sample mean, sample standard deviation, and sample size that we had in the previous example, which allows for us to have a margin of error of 0.14 as the margin of error for that confidence level, and a confidence interval of 5.58 feet to 5.86 feet. So what this means is we're 90% confident that the estimate of our population mean, which in this case would be our sample mean, is within plus or minus 0.14 feet of the actual population mean. So if we look here, we have an example where we're looking at a reporter for student newspapers writing an article on the cost of campus housing. We have a sample of 16 one-bedroom apartments within half a mile of campus. We have a sample mean of $750 per month with a sample standard deviation of $55. So now what we want to do is we want to make a confidence interval at the 95% level to estimate the mean rent per month for the population of one-bedroom apartments within half a mile of campus. And we do need to make the assumption that our data are normally distributed. So what we do is we go down to 15 degrees of freedom. Since we were looking at the 95% confidence interval, that means that the area in the upper tail is going to be 0.025. So 15 degrees of freedom intersects, with the alpha value of 0.025 to give me a t-value of 2.131. And as a reminder, we were able to get 15 degrees of freedom because we had 16 apartments, and degrees of freedom is n minus 1, so 16 minus 1 gave me 15 degrees of freedom for this problem. So now I can take those values and plug that in order to get a value of $750 plus or minus 29.30. So we're 95% confident that the mean rent per month for the population of one-bedroom apartments is within a half mile of campus, being between $720.70 and $779.30. Another thing we need to keep in mind when we're working on problems is whether or not we have a finite population. So when the population is finite, there is a limit to the number of people we can draw from. So in this example, we have 250 families residing in Scandia, Pennsylvania. And so that tells me I have a finite population. We have a random sample of 40 of them with a mean church contribution of $450 and a standard deviation of $75. So here, that's just the sample standard deviation. So because we only have the sample standard deviation, we're going to use our t-distribution. And so the question wants to know what's our population mean? What's our estimate? We want a 90% confidence interval. So if you go to your handy dandy t-table, you're going to move across the top row to get to 0.05 and then move down the rows of degrees of freedom to 39 because we have 40 in our sample, so we have 39 degrees of freedom. And you should find that your t-value is 1.685. And so if you plug that value into the equation, you should be able to solve that the confidence interval is going to be between $431.65 and $468.35. So that means that the population mean could be $445, but it's not likely that the population mean would be like 425 because 425 is not within our confidence interval.